So we are saying, suppose we know that from indices, we said any number raised to power 0 is what? Is 1, not so?
Yes.
Then which means also 10 to the power 0 is also equals to 1. Now members, what we are doing here is all the numbers we are expressing them, they must be to the base of 10. To the base of what?
10.
To the base of 10. Now we want to find other numbers which cannot be expressed to the power of 10. To the power of 10. So how do we get those numbers? How do we get those numbers? How do we get those numbers? So we said it implies now 1 is equals to 10 to the power what? 10 to the power? 10 to the power 0. Because they're equal. If that is true, which mean we know that what is 1? 1 to the power 0 is what? What did we get?
1.
Which means I can write this one as what? I can write this one as 10. I can write that one as what? 10. This is also another example I'm giving. Equals to 10 to the power what? 10 to the power 1. Not so. We can write 10. 10 is the same as 10 to the power 1 because we said any number raised to power 1 is that number. Not so.
Yes.
Now, when we come back to the first one, which means if I introduce log, to base 10 on both sides, for 1 equals to 10 to the power 0. So introducing log, what? Log to base what? To base 10 on both what? On both sides. So which means I will have log to base 10 of what? Of 1, not so? Equals to log to base 10 of 10 raised to power 0. Members, have you seen that?
Yes.
Now, when you remember that, as we said, according to Napier, he said, when we have a number raised to another power, what we do, we will bring the powers in front, not so. Which means this one will remain log to base 10 of 1 equals to 0, 0, log to base 10 of what? 10. But we said log to base 10 of 10 is what? Is 1, not so.
Yes.
Which means you get log to base 10 of 1 equals to 0 times what? Times 1.
1.
So log to base 10 of 1 is equals to what?
0.
So which means, what does this one mean? This one means log of 1 to any base, the answer must be 0. The answer must be what?
0.
Let's prove it with our calculator. What is log of 1? Press log of 1 from your colleague. Log of 1. What do you get? Press for me. The answer is what?
0.
0.
Very good. So which means when you express a log of 1 to any base, in general, we say in general, log to base 10 of 1 is equals to log to base a of 1 equals to what? 0. So any base, as long even if the log is to base 2, even if it's log to base 3, any base, as long as log to of what? Of what?
1.
Of 1. The answer must be what?
0.
0. Members, are we together on that?
Yes.
Yes. So what we shall do, members,
Sure.
members,
Yes.
are you with me?
Yes.
So now we say it implies now, it implies. So we say thus, the logarithms the logarithms, that's the logarithms of any number, the logarithms of any number between 1 and 10, between 1 and 10, lies between 0 and what? And 1. Lies between 0 and 1. Lies between 0 and 1. Lies between 0 and what?
1.
And 1. Why are we saying that? Let's look at some examples that involve that. Let's look at some examples. Take for example, members, log to base 10 of 3. The number is, we see that 3 cannot be expressed into the power of 10. We cannot have the base of 10, not so. Members, are you following me? So if you want to get any other numbers, but that's between 1 and 10, what we do, that one now you get it direct from our calculator or from what we call log table. We get it from the log what? From the log table. We shall see that. We shall discuss that one as we proceed. But for now, let's first write it in. So what is, you press direct from your calculator. What is log to base 10? I mean, what's log of 3? What do we get? We get 0. We get 0.477 what? 1. We write to how many decimal places, members? To how many decimal places?
4.
To 4 decimal places. So in another number, which means you can, this one's the number in a number that's between 1 and 10. If you want to get that logarithm, you either press direct from your calculator or you go and use log table, which we are going to see how we can get them. Okay? Are you together, members?
Yes.
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 Now, this one means, can also, you can say, it can be written as 3.0 equals to 10 to the power. 10 to the power. What have we got? We got what? 0.477 what? 1. Members, are we together? Can be written as 10 to the power 0.4771. Are we together, members?
Yes.
Yes. This is what we call antilog. This one we call it what? When we write it in this form, we call it what? We call it what?
Antilog.
We call it antilog. We call it antilog, which means the number, that number can, it does not have exact value. Does not have exact what? Exact value. Or the number cannot be expressed to the power of 10. The number cannot be expressed to the power of what? 10. That is 1. 2. What about log? Log of 4.
That's result of 4.
What about log of 4, members? What about log of 4? Log of 4 is the same as, let's press our calculator, log of 4 is the same as 0.6021 after rounding off, not so?
Yes.
So this one we said is the same as 4.0 equals to 10 to the power 0.6021. Are you together, members? Are we together? Are we together? Number 3. Number 3. What about this number? What about this number? If they ask you find for me log, the one you are seeing on your screen, are you seeing that example on our screen there? Log to base 10 All this one, they are to base 10 members. All are to base 10. Log of 1.86. 1.86. I said you either use a log table or I use what? A calculator. So here we are still using calculator. Using what? Using what, members?
Calculator.
We shall see how we can read it from the table. Can you press for me that? What is that? Log of 1.86. What is the answer? You get 0.26. 0.2699 what? 95. As simple as that. Number 4. Let's look at number 4. Log to base 10 of 3.16. You just press. What is the answer? Press for me and give me the answer. Press and give me the answer. What have you got?
0.499.
996.
997.
997. Sorry, 99 what? 997. Just like that, members. Just like what? Just like that. What about log? Press for me log to base 10 of 2.356. What answer do you get for that? What is the answer for that? Using our calculator, log 2.356. What have you got?
0.3722.
0.3721.
2 when you run off to 4 decimal places. Are you together, members?
Yes.
Yes, that's how we get logarithm for bases. So we have our log table there. That is our log table. But what I'm going to do, I'm going to send a log table on the WhatsApp group. Then you download, then you print them. Okay. The one which is clear. So let's see, how do we read? But are you able to see my screen very well?
Yes.
Very good. Now we want to see how do subheading, how to read logarithm from a what? From log table. From log what? From log table. We have seen how we can get it from calculator, not so, members. Members, are we together?
Yes.
How to read? How to read? So, are you seeing the table very well?
Yes, teacher.
Now, what was the question? Let's just pick any question from there. The question was, we want to find log of what? 10 to base. We start with which one?
F.
Let's start with 3.16. 3.1 what? We want to find log to base 10 of 3.16. So our argument, our what?
Argument.
Our argument is what? 3.1.
6.
So we come to the table. We come to the what? Remember, I seeing the line of X. I seeing the line of X. I seeing the line of X. That's the numbers. Those are the numbers. Are you together? I seeing it from the table.
Yes.
X is we have 1.0 up to 9.9, but only that this one have stopped at 2.3. So which means we don't have 3 in this table. We don't have 3. Let's look at the one where we have 2. Let's take like which number should we take? Let's look at this one. Log to base 10. Let's say 2 point. The other one was 2.56. Let's look at that one. 2.5 what? So what we are going to do, even 2.5 is not there. Sorry. Let's look at the one which is there in the table. Because I will start from 1 and then stop at 2.3. So let's look at the one which is on the table. Which number should we take?
2.356.
We are taking log to base 10 of what?
356.
356. So our argument is 2.356. Now what we do, you come to the line of X. When you look from the icing the line of X, there are to how many decimal places, members? There are to how many decimal places? They are to 1, not so.
Yes.
We have 1.0, 1.1, 1.2 up to 9.9, but for this one, I've stopped at 2.3. So what we do, we divide them. We pick them in the order. So we pick 2.3. So you go to where 2.3 is. I think where 2.3 is from the table?
Yes.
Go to 2.3. Are we all there?
Yes.
Then we are going to say 2.3 under 5. We read as 2.3 under
5.
We read it as 2.3 under what? Under what?
5.
Under 5. So you come, I think this one where they have started 0, 1, 2, 3, 4, 5 up to 9. Are you seeing that?
Yes.
Are you seeing 5? Are you seeing 5 there? Are you seeing 5 there?
Yes.
Follow that line. Follow that line. Follow that line. I think my cows are there.
Yes.
Until you see 2.3. I think that we are in that line, not so.
Yes.
What is the value there? All the value I think that they start with 0 point. They start with 0 point. So which means that logarithm is what?
0.371.
1 what?
1.
1 plus. But remember, you see, we have not read this. We have left out 6. I think that.
Yes.
Which means what are we going to do? We are going to add. We are going to add what?
6.
I think this one. I think this side where they say difference or add. I think it.
Yes.
So what are we going to add? We are going to add what?
6.
First we are adding 6. So come to I think where my cursor is 6 is there, right? I think that.
Yes.
Yes.
Follow that line until where we were. 2.3 is there. What are we adding?
11.
We are adding 11, and that number must be to 4 decimal places. So it's the same as we are adding. It's the same as 0.011. That's what we are adding. Right together.
Yes.
So when you add that, what do we get? So we shall have 0.3711 plus 0.0011. That's what we are adding. Are you seeing it there, members? So we shall have what? We shall have 2, 7, 3, then point what? 0. Have you seen that?
Yes.
So which means it implies that log to base 10 of 2.356 is equals to 0.3722. Have you seen that, members?
Yes.
Let's prove it.
Yes.
Our calculator. Let's prove it. Let's prove it. Log of what? It was log of 2.356. Not so? What do you get? Is it not the one? Is it not the one? Is the one, right?
Yes.
Another question? Who can add first another one? Just give me anyone. Give me any. Log to base 10 of which one? Who can give us? Members, which one should we do again? Can we find log of, let's say log of 1.423? We have something like that. Are you seeing that?
Yes.
Let's work out that one using a table, using the table. So we are saying we are going to read what? 1 point what? Read what? 1.4 under what?
Under 2.
Read 1.4 under. What do you get? What do you get? 1.4 is here. 1.4 is there. Under what?
2.
Under 2. What is the answer? Is 0.15 to what? 2.3. But are we finished? 3 is still left, not so?
Yes.
So we are supposed to add what? We add?
3.
We add 3. So you come to add. Add 3, follow that line. Make sure you follow the line. Follow the line. What are we adding?
9.
We are adding 9. So you come and say plus 0.00. It must also be to 4 decimal places, members. 0, what? 9. Sorry?
Yeah, 3.
009. Okay? So we shall have 0.15, 23 plus 0.0009. That's what we are adding, not so? Members, are we together?
Teacher, is it 0.132 or 0.1523?
Is 0.1523.
Okay.
Yes. So when you add this one, what do we get? Here we shall, this one will give us 12, 2, 3, 5, 1.0. Have you seen that?
Yes.
So it implies that log to base 10 of 1.423 is equals to 0.1532. Okay?
Yes.
Can we prove it with our calculator? Let's prove it. Let's prove it. Log of 1.423. What do we get? Are you seeing that? Have you seen it?
Yes.
So that's how we read log table. That's how we read, that's how we read values from the log table. Is there any question, members? Is there any question so far? Members, is there any question? So since you don't have a log table, I'm going to give you exercise. Express the following numbers. Express the following numbers as powers of 10. As powers of 10. As powers of 10. A, we have is 100. B. So what I'm meaning here, members, is to put them in standard form. Is to put them in standard what? In standard form. Then I have 100,000. C. I have 6.23. Write them in standard form. D. What about 153? Write for me 153. That's number 1. Number 2, find the logarithms. Find the logarithms of the following numbers. Find the logarithms